Who sleeps? Who's got time for that? Alright. So, just to help us get going, we got to get through logarithms ASAP. Quick recap, big idea. What is a logarithm? An exponent. Don't forget that ever. It is simply an exponent. Did I hear knocking, or is that my imagination? Okay. So I'll write this on the board. Leah, just go with it's 8s and something else that aren't full. Go with the 8s. You can take Christina's papers and just put it on the 2s over there. Oh, there's only 2 4s as well. Whose stuff is that on that? Okay. I was looking at it, I was like, I didn't think I gave out another 4. Kristen's like, there's not another person here, I gotta spread out. Got all my stuff. Alright, all joking aside, pages 171 to 222. Yes, I'm aware that there's no shot at us getting through all that. And so you will be able to throw away a lot of this stuff. No, not tomorrow.
Right.
Well, hopefully a handful of us are still coming to review and master things, because at the end of the day, it's this weird thing where it's not just about the grade, it's about the learning, even if we're exempt. And I was like, oh, why am I going to come to school if I don't have to? But learning still matters. Anyways, all that aside, legitimately, I will say a lot of the textbook pages, a lot of the resources, you probably could throw away. However, maybe the Frere models that have your notes, things like that, if you've stayed organized, I would hold on to those things so that when you go to the next math class, you still have them, especially if you plan on taking pre-calc. If you plan on taking something else, which I'll talk about those other options on Friday, you won't need as much. But if you plan on taking pre-calculus, or even there's an option of Math 100 with Miss Moore that I'd have to ask her again what is covered in that. You'll want to hold on to some of these notes to refer back to later. But let's get into logarithms. So, Unit 7, logarithmic functions. I forgot to update that agenda, my bad. No, that's right. Module 3, Topic 3, Lesson 1. We're going to go over that features homework assignment that I gave you last night. Then we're going to get into these ideas about rational exponents, evaluating logarithms with integer exponents, estimating non-integer powers. And so hopefully that'll go pretty quick. Yesterday, we already have talked about an exponential function. We referred to the power rules. We're going to come back to those in Module 3, Topic 3, Lesson 2, which I just remember that one off the top of my head, but it's more about the power rules than anything else. Trying to think about it. We've done everything on here except for using power properties to simplify expressions. That is a foundational piece, but we'll look at it in that lesson I just mentioned. What we are focusing on right now, so key ideas, things to look for, asymptote, argument, common logarithm, base, logarithmic function, logarithm. We've already covered exponential growth and decay, but those are not the things we're focusing on right now. Any of those key vocabulary terms that I need to recap, remind you of what they are? I'm not 100% clear on. Remember, I can't read your mind. If you got a question, please ask it. Okay, so we're clear on the vocabulary. Right now, what we're going to be getting into is graphing basic logarithmic functions, which let's talk about that for a second, because I want to make sure that this is super clear. Rewrite, so we're going to be practicing that in a second. Yeah, so that's later. So let's talk about graphing basic logarithmic functions. So I'm going to go ahead and tell you, if someone asked me to graph I'm not actually going to use that equation, more than likely, to figure out the graph. Like if I'm trying to graph it by hand, if I'm trying to make a table, what's another thing I could do to help me figure out what the graph of that logarithm might be?
Put it in a calculator.
Yeah, but calculators are lame. Not really, I love calculators, they make life easy. Fours, Shanider's the place we got one left. But what if you were asked, because I'll go ahead and tell you, like, a lot of upper level math classes or intro level math classes at the collegiate level, the only kind of calculator you're going to have is like a basic calculator that doesn't have a graphing feature. So I got to graph a logarithmic function by hand. Any ideas? Can we start with maybe an exponential? Because what's the relationship between an exponential and a logarithm? They're inverses, right? So if I could get the features for the exponential, then I could get the features for the logarithm as well. So what would be the inverse of this function? We don't even have to do a ton of work. I didn't do any transformations on it. What would be the inverse of f of x?
2 to the x.
2 to the x, right? The inverse of that logarithm is that exponential. Comfy with those ideas? Okay. I just realized that the camera probably can't see that far over, so let's do it here. Alright, so I'm going to start here. If I want to graph it, starting with a table is a great option. You can start with a graph if you're comfortable with it, but how could I use a table to help me figure out what the graph of 2 to the x looks like? Say again?
2 equals what? X is 2 and 1.
2 and 1. So like if x is 2, y is 1? Other way? What is Miles referring to that can make my life easy if I don't remember, like where's he getting that if I don't remember the function, huh? Substitute, right? Like if I substitute, my input in was 2 to the first. 2. Okay, what else can I do?
2.
An x value of 2. And 2 squared is 4.
3.
Okay, but yeah, y'all are forgetting some really good points. Like this is fine. 2 to the third is 8. But come on, what are y'all forgetting?
0.
0. Why would I always want that 0? What is that going to give me?
1.
It's going to give me the y-intercept, isn't it? Okay. So the y-intercept, 2 to the 0, or yeah, 2 to the 0 is 1. I might want some negatives in there. Which one's 1/2? The negative 1. How do we know it's 1/2? For those who are scared to say something but may not know exactly where that came from, how do you know it's going to be 1/2? Or Landon? Either one. Or anybody. I'm throwing it out there.
Just like
Put the 1
multiplication
over
of just opposite division.
So, and I do want to point this out. I like what Dewey is saying. Say that one more time. The negative exponent indicates repeated division, right? So 2 to the negative 1, and that's Landon what you're referring to, but this is being more precise with that mathematical language, is 1 divided by 1, 2. 2 to the negative 2 is 1 divided by 2 times 2, 2 2's, so it'd be 1/4. Anyone know of another way to explain why it's 1/2 and 1/4? Don't forget your rate of change. It's multiplicative, right? So in this direction, what are we doing? Multiplying by 2. So what's going to happen to go backwards? Divide by 2. Or multiply by 1/2. So keep that in mind. Understanding your exponentials can be really powerful to help us figure this out. So all that to say, I now come over to my logarithmic function, and I get a nice easy job. What's the first point I might want to put here?
1, 0.
I might do that eventually, but
1/4 the negative 2.
1/4 and negative 2.
1/2.
Negative 1, 2, 1,
2,
4, 2, 8, 3.
So if you can get the exponential equation, then you can easily get, or exponential table, you can easily get the logarithmic table, you can easily get the graph for the logarithm, things like that, okay? So graphing points at that point. I do want to point out, and I want y'all to think through this to make sure that we understand this detail. So this would be log base 2 of 1/2. Well, what's the exponent? What exponent goes on 2 to give me 1/2? -1. Isn't 2 to the -1 this 1/2? 1 divided by 2? Log base 2 of 1. What is a logarithm? It's an exponent. What exponent goes on 2 to give me 1?
1.
0.
Isn't 2 to the 0 1? And so keep in mind that all a logarithm is an exponent. You want to know these integer exponents pretty well. Play with them, practice them. We're going to do that today. But once we understand the integer exponents, we can start to estimate the non-integer exponents. Please notice I said estimate, because if it's not an integer, I'm using a calculator, legitimately. But I want us to be able to think through these things. So understanding that's important. But once again, if I want to get a logarithmic graph or table, I'm going to start with the exponential. It just makes my life easier. Unless you're really, really, really comfortable in thinking through getting these points. But logarithms are a little bit harder for a lot of students to start with. It's easier to substitute into an exponential, get an output, and then transpose. Okay, that's probably what I would do. I would start with my exponential and then get my logarithm. But that also helps if we are practiced with logarithms. Now, this is what I asked y'all to do last night. What was the first part? The function. Okay, so basic exponential. Now, I gave you 2 to the x, but just in general, basic exponential is any base raised to the x. So we use the 2 to the x. And so what was the basic logarithmic function? Log, there's a word that you're forgetting in front of that too. Log base 2, which you can also just call it log base b of x. We used log base 2 of x to be able to graph it and see it more clearly, right? And I want you to notice, if you look at that table and you look at this graph, do we see some of the exact same points from the calculator? Yeah. What exponent goes on 2 to get 1/2? The exponent's -1. Which I forgot to mark this one, but what exponent goes on 2 to get 1? The exponent is 0. So that graph, that table is telling us the same story. We should have a sketch of that graph already done, because we already have the whole thing done, right, Kyron? Brianna, Hope, probably most of us. Guys, I asked y'all to try this last night. So I asked y'all to take a picture. All right, we gotta look at these features, because I needed y'all to practice these features, identifying them. All right, what was the domain of this exponential function?
Which one?
The exponential. Meaning what? What does that negative infinity to infinity mean? Inputs, right? So the inputs go all the way from negative infinity to positive infinity, right? Like it's everything. It's all real numbers. Notice I did say all real numbers, because what numbers am I not including in that? Imaginary. You start putting imaginary numbers in exponential functions, fun things happen, but it's a little wacky at first, okay? So, yeah, negative infinity to positive infinity, all the real numbers. Now, what was the range for that exponential? 0 to infinity, okay?
No bracket.
What?
No bracket.
No bracket? Why not?
Because it never gets to 0. It never gets to 0.
It never gets to the 0. I know it gets really, really close. Does anyone remember how I explained why it never actually gets there? Say again? The asymptote, right? But I was explaining where that asymptote came from. Where did that asymptote even come from? Why does it exist at that 0 here? Yeah, the asymptote's y equals 0, but, and so here, okay, so let's look at this again. I want you to understand this, because if you can understand this, It's not just memorizing, it makes sense, okay? So pay attention to this. Let's say I take 2 and I raise it to the negative 3. What does that equal? 1 divided by,
2 times 2 times
okay? 2 to the negative 7,
1 divided by 7
okay? Then multiplying those 7 2's, right? That's 5, 6, 7. And then 2 to the negative 100. Same thing, but with how many 2's? And yeah, I'm not writing 102, sorry guys, that's just a waste of time. I want you to notice, what kind of number am I always going to get if I take 1 and I keep dividing it by 2? I'm going to get a fraction. So what's it not going to be?
0.
It's not going to get to 0, right? Please notice, if I take a positive number and I divide it by positive numbers, I always get a positive. It's going to get close to 0. It's going to get so small that it looks like it's going to be 0, but it doesn't actually get there. Okay? So that's the idea of that asymptote. If I take positive numbers and I divide it by positive numbers, it just stays positive. It gets close, but it doesn't quite get there. So please note that, and please make sure you try to understand that idea, that it doesn't quite get to 0 because we're taking positives and dividing by positives. Now, remember though, that can change in certain cases. I just want you to think about this. This range, right here, this range would not be 0 to infinity. Because what would the range of just this piece be?
0.
This piece would be the 0 to infinity. So what would my new range be if I'm subtracting 3? It would be negative 3 to infinity. Okay? This is why I want you to understand that idea that 2 to the x, I need to actually open the calculator. While that's loading, I'll just pull up Desmos real quick. So notice if I take 2 raised to the x, I get that function, but if I take 2 raised to the x minus 3, notice how it's now approaching that negative 3. Say again. So say that again though, that's actually important. But notice, yeah, the y-intercept's not negative 3 because pay attention, remember, what is 2 to the 0? 1, and what's 1 minus 3? Negative 2. Right, so again, if you understand your basic exponential function, that's just subtracting 3 from everything, vertically. It actually doesn't change anything horizontally. But those are things I want us to pay attention to and understand. And that's why I'm emphasizing, because we don't have enough time to go into all these transformations. But if you understand that 2 to the x has that 0 to infinity, then it's just adding, subtracting from there, okay? And paying attention to those details. So, paying attention to that asymptote and those ideas. Okay? All right, let's look at the rest of this. So, by the way, before I even get any further, so that's f of x. That's 2 to the x right here. Here's my log base 2 of x. What are those features without even looking at the graph?
Which one?
The domain and range for log base 2 of x.
Domain 0.
The domain would be
0 to infinity.
0 to infinity. The range?
Negative infinity to positive.
Oh, that's why I covered inverse functions. I'm so glad to hear y'all say that. Notice, because my inputs and outputs transposed, they reflected across y equals x. Is my domain, in fact, 0 to infinity? Yeah. Notice that horizontal asymptote became a what?
X.
And x equals a,
0.
well, this was a horizontal asymptote, so it became a
Vertical.
vertical asymptote. X equals 0 now instead, right? Talk more about that in a second. And then it does go down in the range. It goes down to negative infinity and it goes up to positive infinity. Because don't forget, what is a logarithm at the end of the day? An exponent. And what exponents could we have? Anything, right? That's horizontally, my inputs, any exponent. Vertically, any exponent, right? And so that's why we want to understand this idea of inverses and see those features switching. Okay, intercepts. So if I'm looking at 2 to the x, remember this is 2 to the x, what's the x-intercept? Say again?
It doesn't have one.
It doesn't have one, right? Now remember, I just talked about that and showed like I can translate it down or translate it up and that might affect things, but at least for this basic one, what are we getting close to but never getting to? 0, right? It never has that x-intercept. And so, none. Cool. What about a y-intercept?
0, 1.
0, 1. We can see that on the graph, but also, don't forget, Shadija, what does every y-intercept have in common that's ever existed? I'm going to come back to you in a second after someone helps you out. Do you want to throw a lifeline to someone specific? No? You don't want to? No, I don't want Miles. I love him and all, but I'm just giving him a hard time. Leah, what does every y-intercept have in common? You're good. This is something we've covered a lot though. What does every y-intercept have in common?
I'm not here.
You're on the struggle bus. Brianna, what do we know about every y-intercept that's ever existed? Oh gosh, y'all are putting way too much pressure on yourself. No. Davian, what does every y-intercept have in common? What about 0? Sarah, what about that 0? Remember, every y-intercept that's ever existed is on the y-axis, so what's the input? 0. All right, Shadidra, what does every y-intercept have in common? What's 0 though? What is 0? The input, right? The input is 0. 2 raised to the 0 is 1, right? 2 to the 0 is 1, so 0, 1. If you want a y-intercept, substitute 0 in for that x. Okay? Do not forget that. It's okay. I have taught y'all something. I promise. I'm talking to myself, by the way, not y'all. All right. So intercepts for the logarithmic function then. What's the x-intercept? Do we have one?
No.
It's 1, 0. Remember, my inputs and outputs transposed, so 0, 1 became 1, 0. Right? Y-intercept? None. Okay? Again, that can change with transformations. That's the basic part. Again, I also want to point out, if I ask you what log base 2 of 1 is, what is a logarithm? It is an exponent. So what exponent goes on 2 to get a 1? 0. That's why it's 1, 0. Right? That input, that argument of 1 has an output of 0. Asymptotes. What's the asymptote for f of x to 2 to the x? What is 0 though? What's equal to 0? Yeah, there's always a little bit of debate about this, and I want to remind y'all, so I know the tendency in math is to memorize stuff, but does anyone remember an easy way to quickly see if it's y equals or x equals?
No.
No? You might want to make a note of this, because it's about to make your life easy. This is where my y-intercept is, correct? Or my asymptote is, right? Yes, Mr. Kenny. Thanks, guys. Hey, what does every point on this this asymptote have in common? The y is 0. So you know what the equation is? Y equals 0. That's it. Remember, an equation is the equation because every point makes that equation. Every point makes that equation true. So literally, what are we saying? Well, the y is just 0. It doesn't matter what x is, the y is 0. And so if it was y equals 0 for 2 to the x, what is the log base 2 of x? X equals 0, right? That would make sense, wouldn't it? And you can check it if you're not 100% certain. This is 0, 6. This is 0, 4. 0, 1, 0, -1. So is the x equal to 0? when we have vertical and horizontal lines, like, it always tripped me out, and I struggled with this in middle school and high school for the longest time, because I was like, but it's horizontal, why in the world is it y equals? Well, because literally the y is equal to 0. But that's it. It's vertical, so why is it not a y? Why is it x equals 0? Because literally the x is equal to 0. If you have horizontal and vertical lines, plot a few points, see what's the same. Because the whole idea is that every point should make that equation true. That's the idea of a solution, is it makes the equation true. So please note I'm trying to give you that heads up on thinking through why this is true, not just memorizing, because memorizing is not useful. Understanding, that's useful. When we memorize stuff, we forget it eventually. When we understand, it takes way longer for it to go away. Usually I like to write it vertically, but for the sake of space, that's our end behavior. What are your questions about those? So notice I just did the left-hand side horizontally, or I did each of them horizontally instead of stacking them vertically as I normally do. Everyone's comfy with these things? What are your questions before we continue to the pages you just tore out? Going once. Going twice. Sold. I thought Pam was about to ask a question. She threw that hand up. She just wanted to say hi to her bestie. All right. So remember, end behavior, really just circle those ends, pay attention to it. Like, it's going left for forever, so x goes to negative infinity. And what's the y going towards? Why should it make sense that y is going to a 0 here?
It's going towards the
Yeah, but what's that called? It's the asymptote. Remember, use the asymptotes to inform your end behavior, use your end behavior to inform your asymptotes, right? Y is going towards that 0 there. X is going towards that 0 here. So pay attention to those things. Okay. Based on lack of questions, we're about to get going. So this is the second half of logarithms, focusing on the actual operation, focusing on solving equations with logarithms, solving equations with exponentials, the whole kit and caboodle. We good? What?
No, that's not.
No.
I asked him if he had ADHD.
So it should say,
And
because
he said no, and I said, have you been tested? And he said no.
he's hyper.
I said,
Yeah,
you
it is.
probably should be tested.
No comment. Right here. So this is page 172. This is the getting started. This is to help us really reinforce some of the ideas of logarithms and exponentials. Because we're not going to cover it, okay, I want you to not do this one that has that L in there. And I'm going to use some of these to explain some important ideas that we haven't had a chance to do yet. But, yeah, the one with the L in, that's the base E that I told you we're not going to do. Let's do this. Let's take 5 minutes. Please notice all we're doing is going either from the exponential form to the logarithmic form, or logarithmic form to the exponential. So work with each other. let's convert, do we need to do one of these, or can we use what we did yesterday and get going? Huh? Just one of them?
Yeah, just one.
Is that because we want to think, we don't want to think? We want to answer?
Something like that.
Something like that?
I don't know how to think.
You know I'm teaching, right? What's up? No, I'm good, thank you though. Yeah. Alright, so 12 squared equals 144. So what would be the logarithmic form of that? Okay, gotta start with the log, sweet. What's next?
Base 12.
Oh yeah, same as the exponential, cool, I'm good with that. Of 144.
And then equals
Why should that logarithmic form make sense? Yeah, why should that make sense? There's two huge things to note about it. You're not wrong, but let's rethink that in the language of logarithms then. When you say 12 times 12, what's another way to say that? 12 squared, right, is 144. So that's what we originally started with, so why does that make sense here for the logarithmic form? You're really onto something, but say again. They're inverses, so how does the fact that these are inverses inform that it should be log base 12 of 144? Think about the language of inverses. There's some key ideas. It's the defining characteristic of what a logarithm, or what an inverse is. What transpose? Come on. Inputs and outputs. So what was my output has now become my input, also called the argument, right? And what is a logarithm always equal to? What is a logarithm equal to?
exponent.
An exponent. And so this exponent became my output. Ooh, thank you. So the input of an exponent became my output of an exponent, and the base is the base. Right? So keep in mind when we talk about that idea of a logarithm, the output, original output of the exponential now becomes the input. And so once again, the question is, hey, what exponent goes on 12 to get 144? 2. Boom. That's what the logarithm is. So I'm going to give you 5 minutes at this point. I want you to work within your small group. I'll let you choose at this point. Do you want to do it at your desk or go to the vertical surfaces? But I want you to fill out the rest of this table. Some of these you may not be comfortable with why that's the correct thing, but I will explain it soon. You're not doing the one with the LN, the natural log. Yep. You do which one?
Wait, which one are I don't know if that's right.
Oh, I'm sorry. Is it really tough for you? The whole thing is a struggle. Yeah, come on, do it. You can. It has not changed. Looks like we may not even need 5 minutes. So here, talk with each other though. I see some of us that are way ahead of the rest of our group.
Yeah, I just think it's, I think it's
Oh, you didn't tear that page out? Or at least talk with your group?
I would.
Okay.
I'm not gonna go with that, but we find the page.
One word caution.
That's what I'm saying.
Okay. One word caution really quickly is this.
Yeah.
That looks like an exponent. You see how that's even above the logarithm? The argument's always written in line with the logarithm, and the base is a subscript. Because remember, it's equal to an exponent. It's not an exponent. So be careful. Does that make sense?
So since I'm done, I'm just walk off.
When you do that,
You can. The whole base is 2/3, right? So if that helps, you go for it.
What?
Jaden did grab my paper. Grab it.
I'm talking about it. Got some questions. I'm good. Say again. But like, y'all can talk it through as you're doing it. That can help build better understanding.
Why?
I do want y'all to talk a little bit more, because I'm just looking at year two, right, because not everyone has a twin out. But looking at y'all two, y'all have very similar ones on most of them, but there's a small differences, so I want y'all to compare your answers and talk. All three of us. Talk with each other. No. Do that equation again.
Hi.
What did you get for number 2?
16 to the 1/2 equals 4.
Okay.
I did 2.
Logarithm, right?
Yeah.
Okay. Has not changed. Remember, I said don't do that one. So, all of that is, you will study this next year.
It's log,
What's that equal to? Approximately equal to 3. It's not confusing. When you see this, that just means log base E. That's that E number that we're not getting. That's all that means.
You gotta take calculus. No, that's algebra 2. You gotta take statistics.
Well, there's like a little bit of statistics within algebra 2 at the beginning, but there's also that AP stats class. Okay. So one thing I want to point out to you, remember, what is a logarithm equal to?
Oh my goodness. So you don't have to see.
An exponent, right? Is 36 your exponent?
I know.
It's what? What's the exponent? X. So what should this equal? Remember, whatever your output was is now your input. You said the input is 36. The output is X. Alright, so we may not be completely done, but there's two things I want to talk about based on what I'm seeing, and then I'm going to explain a couple of things. But I need y'all to be careful about something. Please pay attention to this. This is the most common mistake I see students do all the time when it comes to logarithms. So first things first, do not forget, what is a logarithm equal to? And exponent. So whatever your exponent is, that's what the logarithm needs to equal. But I want y'all to look at this. This is a little bit better than what some of y'all are doing, but this is not quite written correctly.
Why? Because it's not log.
Because 100,000 is above the law.
Okay, so it is a log, but notice how that 100,000 is a little bit above, almost like it's a what? An exponent. But remember, a logarithm equals an exponent, but make sure you are careful and you need to write your argument in line with the logarithm. Okay, write your argument in line with that log, and it's just that 10 is a base. Okay? So be careful with the way you're writing it. I think I saw 4 or 5 of us doing that. So please look at all of your logarithms. Make sure your argument is in line with the logarithm. That's just notational. That's something we got to be careful about. We go with that. Going once. Going twice. Sold. Okay. Next one. Which of these... we may have gotten right, but which of these kind of freaked us out? There should be 2 or 3 that I, off the top of my head, that were like, how in the world?
Right.
I was thinking 2 behind, I mean, under the line.
Whack.
So these 2 right here?
Yeah.
Yeah. And usually even for students, this one, okay? But let's talk about this one right here first. 2 to the 3rd equals 8 divided by 27. Now again, if you understand an exponential, this hopefully makes sense. You don't have to put that in parentheses, just make sure it's a subscript. But here's the thing, even with a fraction, instead of thinking about it the fraction, just think about the numerator and think about the denominator. 2 to what power gives me 8? 2 to the 3rd, right? Now I want you to notice and think about it this way. 3 to what power gives me 27? 3 to the 3rd, right? Because the whole idea is, when you are multiplying or dividing, there's actually a distributive property with exponents. Don't stress it a ton, but that's the same thing as just 2 cubed divided by 3 cubed. And so even though that's a fraction right there, the idea of the exponent still holds. 2 to the third and 3 to the third. That's how we get the 8/27. Does that answer that question, Peyton? Does that make sense?
Mhm.
So keep in mind the fraction base. That's all it is. Does not change whatsoever. Typically though, students look at this one up here and they're like, how in the world is 16 to the 1/2 equal to 4? Have I talked about those fraction exponents in this class yet?
No.
No? Okay. So, when you see a fractional exponent, this is all it actually is. The denominator, that's actually a root. The numerator is actually your exponent. So what root am I doing of that 16?
2.
The second root, or the square root. What's the square root of 16?
4.
4, and what's 4 raised to the first?
4.
That's all that is. The denominator of a rational exponent like this is a root, and then the numerator is your actual exponent. So when I look down here and I see 9 to the 3/2 equals 27, what root am I doing here?
Square root.
I'm doing a square root, right? That's it. What's the square root of 9?
3.
And then what's 3 to the third?
27.
That's where that's coming from. Please make a note of this to yourself, that when we have a fraction, and write this down because did not have enough time to cover this in the last unit, but it should have been there. Hopefully you talked about it some in Algebra 1. If not, you need to know this. But the b, right there, is my root. The a is my exponent. And so it's the bth root of x to the a is essentially what it is. I will point out, actually, I would probably do the root first and then the exponent. I would personally always do the root first, then the exponent, if I can easily simplify. Otherwise, we're just going to leave it like that.
So what you do if it's higher than 2?
Say again, sir.
So what you do if it's higher than 2?
Say it louder.
What do you do if it's higher than 2?
Oh, same thing. What root do I have right here? The third root, or cube root. What's the cube root of 27? What was multiplied 3 times to get 27? 3. So this is the same thing as 3 squared, or 9. So it doesn't matter if it's higher, it's still the root. If I look at 16 to the 3/4, and I know that we're not necessarily super comfortable with roots, we will have calculators a lot, but I do want us to conceptually understand this. What would the 4th root of 16, what can I multiply 4 times to get 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. So what's the 4th root of 16? It was 2. Didn't we multiply 2 4 times? And then so we have 2 to the third, which is 8. So 16 to the 3/4 is just 8. Do your root first and then your exponent. Anyone know logically of a reason that we might want to do the root first?
No.
Nothing? Tell me this, Crystal. What is 16 to the third?
316.
What?
What?
16 to 30?
16 raised to the third.
I don't know.
Same. I know 16 squared is 256, but 256 times another 16, bump that. When you do a root first, it makes the number smaller first. It's easier to deal with small numbers than it is big numbers. So I do a root, make it small before I do the exponent. That was my point. I got no clue what 16 to the third is off the top of my head. 4th root of 16? Oh, 2 times 2 times 2 times 2. Why do you look like that, Peyton?
Cause
I had prices out of it for a second.
Okay. So personally, I would just do the root first, then the exponent, if you're going to do it by hand. And I will make this note. The reason why I'm pushing this right here, right now, is when, or if, which again, I love calculus, but not everyone needs calculus unless you're doing some kind of STEM-related field. But if you take a calculus class, you need to be comfortable with rational exponents. Because something called a derivative, something called an integral that you don't need to know yet, you can't do it with radicals. You can do it with rational exponents though. Okay, so understanding that rational exponent is critical for a calculus course. Okay. You good with that? Peyton, you good? Okay. Alright. So, let's get some practice. Any of these other ones, by the way, that freaked us out?
No.
We comfy?
Yeah.
Okay. So, here's just some practice or some information if you want to read through the book later, but we've already covered all these ideas. What I want you to do is this section right here on page 173. I just want you to figure out how to arrange these three numbers using a logarithm to make a true logarithmic statement. Okay? Sure. But I would also like you to think through these things. Okay, so I'm going to give you 4 minutes. Let's do it this way. Let's go aces through jacks. I want you to do A and B. Tens through fours. I want you to do C and D. And then let's put those on vertical surfaces so that everyone around the room can see each other's afterwards, okay? So, aces through jacks, A and B. I couldn't actually read it because our arms across it, and I assumed, but you know what assuming does? Okay, so I didn't want to completely assume. That's why I asked a question. I'm sorry, I know. You ask questions and you look like an idiot, but nah, questions are good. So, I want to point this out. Notice, like B right here is a more difficult one for a lot of students to figure out. So, instead of thinking about the logarithm, what did this group do over here to figure it out? What did they do? They wrote a bunch of what? Not just random numbers. How did they write this around to help them get to the logarithm? They wrote it as what? Exponents, right? Like when I think about a logarithm, I'm thinking about exponents, right? And so when I think about 1 divided by 216 to the 6, is that going to equal -3?
No.
Remember, that's 1 to the 6 divided by 216 to the 6. That is not a -3. That's a positive divided by a positive. Right? Right here, 1/16 or 1 divided by 216 to the -3. By the way, what does that negative exponent indicate? Division, right? So because there's already division, it's actually just going to go into the numerator. Notice it became a positive exponent now because I took the reciprocal, I did the division. Well, that's definitely not going to equal 6. That's huge. But 6 to the -3 or -3 to the 6, once again, that's not going to equal 1 divided by 216. But one of the groups I was talking about, I really liked what they were talking or discussing. I think it was Hope who recognized, hey, the -3 needs to go over here because what is a logarithm equal to? Logarithm is an exponent, right? I need us to recognize that a logarithm is an exponent. And I got Taylor to rewrite that logarithm for A as an exponential, we talked about it, but a logarithm is equal to an exponent. And what does a negative exponent tell me to do? To what? To divide. And so hopefully we're getting more comfortable with this. I want y'all to quickly realize that that negative exponent is what's creating this division. So we don't have to play around with it as much. We can jump straight to here where, if I do 6 to the -3, that's 1 divided by 216. That's it, right? Like that negative exponent is what's creating that division. I want us to notice that detail. How we feel about B with that. That negative exponent is creating that division. Okay? A couple of things I want to look at over on the chalkboard wall because I like a couple of things for sure, that were done over here. So, first things first, make sure you check yourself, right? I initially heard log base 4 of 1 is equal to 4, but two things about that. Right here. What exponent goes on 4 to give me 1? 0, right? So that would be equal to 0, not 4. Boop. But log base 4 of 4 is 1, right? 4 to the first is 4. But what I really want us to note over here is this. To explain this logarithm, okay, I didn't see this until a minute ago, but notice they took that logarithm and what they do to that logarithm. What's going on there?
Wait, which one are you looking at?
This logarithm, what did they do?
Yeah, I don't know.
I may be
I see
overstepping.
it, but
Tell me
I
if
don't
I'm
know.
wrong. I think originally we just had this. Is that right? That's what you did there? Okay. And then from there they wrote this to get to here. So what did they do? Okay, something that they did to one side, they did to the other. That's called a property of equality. But what are they doing there with that property of equality? They're using an that one. They're using an inverse, right? What's the inverse of a logarithm? An exponential, right? So we had a logarithm, but they made that logarithm an exponent so that these canceled. And so 4 is equal to 4 to the 256. Is that true?
Oh, yeah.
I want you to think about it. That means I'm multiplying 4 how many times?
256.
Is that going to equal 1 4?
No.
No. That can help us visualize and think about it. Whereas if we check it here, so they were trying to think through that exponential, and that's why they ended up going with this one. Notice they didn't circle that, but if we do 4 raised to that, 4 raised to that using those inverses, is 256 going to equal to 4 raised to the 4th? Maybe. One thing I will say is break things down. What does 4 to the 4th really mean?
4 times 4.
And what's 4 times 4?
6.
And 16 times 16 is 256. You also will have calculators for some of these things, but I need us to justify. Something like 256 I would not expect you to do without a calculator, but smaller numbers, smaller exponents, I will ask you to be able to do without a calculator to show that you understand what a logarithm is. Huh? Yes. Because here's the thing. If I want evidence that you understand what a logarithm is, you can just type that into a calculator, right?
Mm-hmm.
Oh yeah, okay.
Because I would.
And I would too, right? If I got a calculator, I would just type that into a calculator. However, there would be a non-calculator portion because I need to see that you understand what a logarithm is as an exponent. What exponent needs to go on 7 to get 1 divided by 7?
A negative.
A negative. A negative what? Ah. So do you need a calculator for smaller numbers like that?
No.
Okay. Alright. So that's what I would want to see. Not necessarily this, but like at least that logic, that argument. You could write this out, you could use words, but I need to see that you understand 7 raised to the negative 1 is 1/7. Okay? How we feel?
Great.
Crystalline's feeling awesome. Drake? Other than tired about the math, how we feeling? Alright. Shadidra? Landon?
Good.
Good. Leah? You awake yet? Ish? Brianna? Bella? You look like you were about to say no. You sure? You lying to me? Alright. But once again, do we need maybe a little bit more practice with these ideas? 100%. Alright, so here's what we're going to do is yeah, I'm going to skip that because that's dumb. Okay, so number 3. All right, number 3 on page 175.
Don't touch that.
You have the skills. I want you to do, I'm going to pick a few of these. Okay, I definitely want A, B, and D. If you finish A, B, and D before we come back together, I do want you to do E and F. I'll explain why I don't necessarily want C. But we'll look at C later. However, so let's get to our vertical surfaces. Let's do A, B, and C. Once you finish A, B, and C, I want you to start working on E and F if we have not come back together yet. Let's get after it. Just rewrote it as an exponential, right? 8 to the n is equal to 64. Over here, like Xander used inverses to get the same exact effect, right? So you can use inverses, you create that exponential to figure these things out. But also at the same time, what is a logarithm? What do we mean by a logarithm? An exponent. What exponent goes on 8 to get 64?
Gotcha.
2, right? 8 squared, 8 to the second is 64, okay? A big thing that a lot of us noticed here, I'm really glad for, is we notice it as a negative exponent, so we got to have division, right? And what squared gives me 16? 4 squared is 16, but because there's the division, we needed, that's why there's a negative here. Now, I didn't ask y'all to do this one, but really quickly, this is why I didn't ask you. Any idea what I would have to do to 1/2 to get 64? Any guesses?
Nope.
What would I have to do to 1/2 to get 64?
What?
Not
Wouldn't it
square
have to
root.
be? Yeah, I don't know.
Because remember, a square root
The
of
exponent
1/2 would
has to
take
be
the
a
square root of
whole
1
number,
square root
wouldn't
of 2. That's not going to get it to
Oh, I
64.
No, it would have to
Listen,
be
I'm
negative.
just guessing at this point.
Say that again.
And the n has to be negative.
The n would have to be a negative. We have division, but we don't want a fraction. We want it in the numerator, right? So n's going to have to be a negative.
How does a negative give you?
And what power would I need
Chance,
to put on 2 to get 64? Yes, ma'am.
Oh, I was just gonna ask, how does a negative give you 64?
So remember how, so like if I do 2 to the, let's say negative 3, that's going to give me 1 divided by 2 divided by 2, right? So if I take a 1/2 to the negative 3, and I don't always write it out this way, but essentially what I'm doing is 1 divided by 1/2 times 1/2 times 1/2. But do you remember how we divide by a fraction? You multiply by its
Reciprocal.
reciprocal, so then we would just get 1 times these reciprocals. So when we do a fraction like that to a negative exponent, it just takes the reciprocal. Okay? And so it's easier to go from a whole number to the fraction, but the same thing's going to happen here. So to go from that 1/2 to that 64, it's got to be a negative exponent. Well, 2 to what power gives me 64? What's 2 times 2?
4.
Times 2?
8.
Times 2?
Wait,
Times 2?
Wait, hold on.
Times 2?
Yeah, I can't go that far. I can't go very long.
So I multiplied 6 times? But it had to be a negative to get
How
that
do you
reciprocal.
zoom in?
Is this supposed
Not-
to be zoomed in?
I mean, if it would make it easier to see, sure.
Yeah, how do you do that?
It's right here, right?
No.
It's on top.
Oh, this? Look, I don't want to bring
I'll
it.
say, just so you know, your finger's like straight in the middle of that camera. Alright, now D, the only thing about D that freaked some of us out, I think, at first was we forgot that a logarithm without a base is understood to be what base? Base 10.
And
What's your question, Miles?
law. Wait, no, we gotta see Mr. Kenny in it.
Yeah, we might want to look at that number again in a second, but what is a logarithm when there's no base written, or what base is it? Base 10, okay?
Base
So
10.
10 to the negative 3 would be equal to n. Now be careful, that means that we are dividing by how many tens?
3.
So how many zeros would this need?
3.
3 zeros. Not 5 zeros. Just be careful with that. So should have been 1/1000th. So remember, a negative exponent just indicates division, and that's it. Okay. Now E and F, we're going to extend our understanding a little bit. So notice right here, Bella started to write this out. The only thing that I would point out to help make our life a little bit easier is we want to recognize this 2/3 needs to be a what? An exponent. So make sure it's clear that it's an exponent. Does anyone know of a way that we can handle this now? How'd you know it was a 7? Seems like a jump. I don't know. Actually, I do know. What's your evidence? It's just a guess.
I mean, I looked at the problem, I just said 7, probably mess up there.
Can anyone give us maybe evidence for or against the 7?
And they cancel out
What cancel out?
the 3 and the cube
So remember, this 3 right here literally means what?
root.
What type of root? So this cube root's the same as this cube root, right?
Mhm.
So n squared would have to equal 49. So what squared equals 49?
7.
7. Now, a couple of things I would point out to you about this is, and so please hold on to this as well. What's the inverse of a cube root? A cube, right? The inverse of a cube root is a cube. Okay, so if I cube both sides of this equation, this cancels, correct?
Mhm.
Now, I also want you, so I'm just giving further evidence and explaining to help build some understanding here.
Yeah, because
I would cube this side, correct?
Mhm.
Does anyone remember how we raise a power to a power or what ends up happening there? The power rule, but like, what do we do with those powers? We multiply them. And what's 3 divided by 3? 1. So once again, n squared equals 49. So remember, it's quite literally a cube root. So when I cube a cube root, that cube cancels out the cube root. That's what we're seeing there. And we can tell here that n is equal to 7, but also I could take a square root. So using inverses still holds. I will say, I do not use the -7 here. Any guesses why? I do not use the -7 here. Because remember, when I take a square root, I should get a positive and a negative, right?
Mhm.
So why am I not using the -7? Ties into the way this was originally written. Has something to do with the fact that this is what I'm solving for.
It can't be doing today.
It cannot, what cannot be? The base, and it can't just be below 0, it cannot be 0 or less than 0 or 1. Do not forget that that base of a logarithm can't be a positive, it can't be 1 or less than or equal to 0. So that's why I ignored the -7. That is a solution when we solve this, but it's not a solution that actually works. That's what we call an extraneous solution. So it's something we get, but it doesn't actually work, okay? All right, we need to look at some estimating when it's not an integer exponent. And that'll be what we end on today. I will ask you tonight to do some check your understanding here. So these 4 problems, check your understanding. We're going to go over these. First thing tomorrow, try doing them without a calculator. I don't want to give the answers for these right away. Well, be careful. We're not solving here. Do you know why I say we're not solving?
I'll do them in Richmond. I'll be back.
Say again.
I'll do them in Richmond. I'll be back.
Okay. So, listen to the language though. When we say solve, what does that word solve mean mathematically?
Trying to see if it's
What
true.
makes you?
Find what makes the
Equation
equation true or inequality true. Hey guys, what do I not even have here? Hey, what? Someone said it. I don't have an equation. Guys, I can't solve if I don't even have an equation or an inequality. So, hey, I don't have an equation, can't solve it, but what could I do? It starts with an, it has another S word. Simplify.
How you simplify?
Huh? Well, what is a logarithm equal to?
Exponent.
Oh, so we gotta find the what?
Exponent.
The exponent. Now, one thing I do want you to point out, hey guys, right here, I want to point this out. Notice it does say write 3 logarithmic expressions that are equivalent to each of these. So I need to find the exponent first, and then write some logarithmic expressions that would be the same. So I guess I could go ahead and give one example. Right here, does anyone know what log base 7 of 1/7 might be? Hopefully.
Didn't we just do that?
Negative 1,
Yeah, we
right?
just did.
That negative would tell me to divide. I'm dividing by 1/7. So, I don't know, maybe log base 3 of 1/3.
-1.
Would that also be negative 1?
Mhm.
So is that equivalent to this?
Mhm.
Okay, so that's what they're asking you to do. They're asking you to write 3 expressions that are equivalent. I mean, I could get real funky with it, like
Just don't. Please, you ain't got to.
Can we write explanations too, or no?
Wait.
logarithmic.
So it's just like
Wait, we just doing that?
multiples and
I'm not trying to.
Yeah.
She said questions are good.
There's infinitely many correct solutions here. So, I just need you to come up with 3 logarithmic expressions that you think might be equivalent to the logarithmic expression given. Okay? That's it. But for them to be equivalent, they have to have the same output or same exponent. Or you can-
I'm not doing it.
Why do you-
I'm not doing it.
Why are you not working? Okay, we should be looking at page 176 right now. There we go. Okay, so,
Do I stop? Do I stop?
nah, keep it going.
Okay. I'm gonna zoom out though.
Actually, I would rather y'all do this than what I was just showing you. We'll do a few of these really quickly.
I'll take that.
Okay, so right here, I want us to pay attention to, this is to help us think through logarithms. This will be way better. Please notice, what is log base 2 of 1/2? Log base 2 of 1/2 would be?
Log base 2 of 1/2. Negative
log-
1.
Negative 1, right? That's telling us to divide by 2 one time.
Mhm.
Notice what is it lined up under?
Negative 1.
Negative 1. Right? Log base 2 of what would give me 0? What does the argument here need to be? Log base 2 of 1, does that give me 0? Yeah. Notice right here, log base 2 of 4, what is that going to equal? Log base 2 of 4 is 2.
2.
What's that lined up under?
2.
2. Okay. So this is just to help us practice seeing some of those basic logarithms and think through some things. So log base 2 of what right here to get 1? And at least that's what someone said. So if you're struggling with this, think through a logarithm as an exponent. What is 2 to the first? 2. So this output became the logarithmic input. 2 to the 0 is 1. And so think through the exponential side to help you get these. Alright, so I do want you to do this for check your understanding. So figure out what goes for that logarithm in each of these spots. And then notice we're doing a logarithm base 3, base 4, and base 5 with each of those. Okay? To help us understand our integer exponents. We're going to go through that tomorrow. Okay. This is what I want us to think through, okay? Alright, right here. So this is page 178. This is the last thing with evaluating logarithms. Again, this is the non-integer logarithms. I want you to practice with the integer ones tonight as check your understanding. But I want us to look at this together. Log base 2 of 10, okay? What is a logarithm? It's an exponent, right? Okay. Does 2 to any power give us exactly 10? No. Okay, so what's a power that's close, that would give us close to 10 though? 2 to the third, what is that? 8, okay. What's next? 2 to the 4th would equal, okay, so what do we know about our exponent just based on that logic? We know our exponent has to be, well, be careful, not between 8 and 16, between 3 and 4. I want us to understand and note that when we look at this logarithm, all I want us to see is, hey, that exponent has to be between 3 and 4. And do you think it's closer to 3 or closer to 4? I mean, 10 is closer to 8, isn't it? So it's probably closer to 3? I don't know, so maybe 3 point what? 2? Alright, let's check ourselves. This is just an estimate. What do you think? Let's type in log base 2 of 10. What's that get us?
I don't have to.
So remember, log is just above the exponential 10 to the x. Yep. That's why they're there, so that they're inverses of each other. Log base 2 of 10.
It's 3.32.
3.32, were we pretty decent? Somewhat, right? A little off, but like, we're just estimating. All I need us to recognize is 2 to the 3rd is 8. It's going off? No, I did not hear that. I hear it now. Hello? You're good. Will do. No problem. Alright, so 2 to the 3rd, 2 to the 4th, oh sorry. So, we just need to recognize 10 is close to 8, close to 16, but closer to 8. So the exponent is closer to 3. This is why I want you to understand a logarithm is a what? An exponent. So now, when I look at something like this, B usually freaks students out. Okay? But what's a power of 5 that can get me close to 4? 5 to the 1 is what? Now notice that's a little bit bigger than 4, so now I need something that is smaller than 4. So 5 to what power? Is equal to, okay, so what do we know about our exponent? It's got to be between 0 and 1, correct?
Yeah.
You think it's closer to 0 or closer to 1?
0.
1. Say 4 is pretty darn close to 5, isn't it? I don't know, so maybe, what do y'all think? Let's go with a guess. 0.8. Cool, let's try it. Type in log base 4, or log base 5 of 4. Let's find out what it might be about.
0.86.
Oh, 0.86.
That's what I got.
So pretty good? And so this is it. Like, I need us to understand and think through these logarithms to figure this out. Okay? We got 3 minutes left. I just want you, as a small group, D will be easier to access. So, as a small group, just take 1 minute, try to think about what you think D might be close to. So phase 10, oh, so yeah, 10 to the 3rd and 16 to the 3rd. 10 to what?
Yeah, the common law base is 10. You'll take 10, you get 10,000. But if you take 4, you'll get 10. It's closer to 10. Why are you laughing? I'll probably be like,
Oh, I'm wrestling with it. But yes, you can do that. But, so you do notice your base here is 4. So you can think about 4 raised to maybe the 5th. Okay, that's too much, so maybe 4 raised to the 4th. Okay, that's less, so it's gotta be somewhere between. Alright, so, I actually wasn't sure if this was gonna work right away, but please note, what is 10 to the 3rd? 1,000. What's 10 to the 4th? 10,000. So, our exponent, our logarithm, has to be between what two numbers? 3 and 4, okay? And is it gonna be closer to 3 or closer to 4?
Three.
Closer to 3, so maybe 3.3,
3.4.
maybe 3.4.
I'm telling you, it's
Huh?
3.4.
Oh, it is 3.4? So notice, ladies and gentlemen, logarithms don't have to be scary. Don't go to a later class and be like, oh, logarithms are the worst. Guys, logarithms are just an exponent. Tomorrow, we're going to wrap up with solving logarithmic and exponential equations. Probably at DYU on Friday. Please do check your understanding questions. But fantastic work, fantastic growth. I love you today. Let's continue until tomorrow. I love my job too. It's great.